Today we are going to look at the bones of the forelimb: scapula, humerus, radius and ulna, carpal bones, metacarpal bones, and the phalanges. Let's start looking at the lateral view of the scapula. So here we see the lateral view of the scapula. The bone is held as it would be present in the live animal, which is in an oblique fashion. So we see a flat bone with two distinct surfaces and three distinct borders: the dorsal border of the scapula, the cranial border of the scapula, and the caudal border of the scapula. On the lateral side, we also see the spine. The spine extends right from the dorsal border all the way to the ventral end of the bone, but at the ventral end, it becomes slightly expanded, and it also shows a structure slightly deviated backward. That structure here is called acromion process. So that is the spine of the scapula with, at the distal end, the acromion process. The spine of the scapula in the dog is very well formed. It is quite wide. On the medial side, as we turn it to the medial side, now we can see the medial view of the scapula. Again, same borders can be seen from the medial side as well: the cranial border, the caudal border of the scapula, the dorsal border of the scapula, and the medial surface of the scapula is visible. Here we notice the three distinct areas of attachment for the muscles: attachment area for the serratus ventralis, attachment area for the rhomboideus muscle, and attachment area for the subscapularis muscle. So this is also called subscapular fossa, which accommodates the subscapularis muscle. The dorsal border of the scapula looks slightly rough as compared to the other borders because slightly developed cartilage would be present along the dorsal border of the scapula, which is called scapular cartilage, is lost while processing of this bone. The scapular cartilage is quite well formed in other species as compared to the dog and cat. As we come further down to the distal end of the scapula, first we'll look at the lateral view, ventral view, and then we'll come to the medial view of the scapula. On the lateral view again, we see the acromion process at the distal end. The cavity which is present at the distal most part of the scapula is glenoid cavity, which accommodates head of the face from the shoulder joint. Superior or in front of the glenoid cavity, we have a tubercle located here, which is called supraglenoid tubercle, and on the caudal aspect of the glenoid cavity, we see the infraglenoid tubercle. The infraglenoid tubercle as well as supraglenoid tubercle are the areas which are rough, indicating that these are the attachment areas for the muscles. So this is your supraglenoid tubercle. Then caudally we have the infraglenoid tubercle. As we turn the bone and look at the medial view of the scapula, at the distal end, on the medial aspect of the supraglenoid tubercle, there is another small process or another small extension is seen, which is called coracoid process. So this is your coracoid process of the scapula, which is located on the medial side of the supraglenoid tubercle. As we come further down to the ventral view of the scapula, we can see the glenoid cavity clearly, which is concave in nature. The hole in the center is for the purpose of assembling the skeleton. Seen from the ventral view, we see the acromion process, the spine of the scapula, and the glenoid cavity with supraglenoid tubercle located here along with coracoid process on the medial side, and the infraglenoid tubercle located here on the caudal aspect of the glenoid cavity. In the lateral view, we can see the spine of the scapula right in the middle, which divides the scapula into two regions: the region superior to the spine, which is called supraspinous fossa, and inferior to the spine, that is your infraspinous fossa. The humerus of the dog. Here we see the lateral view of the humerus of the dog. A typical long bone with proximal extremity, the shaft of the humerus, and the distal extremity of the humerus. The major structures on the proximal extremity are going to be two tubercles, the lesser and greater tubercle, and the head of the humerus. The neck is the constricted portion right below the head of the humerus. From the lateral view, at the proximal extremity, the major structure that you observe, those are the greater tubercle of the humerus, this entire structure. As we go further backward, we see the head of the humerus located more caudally, that rounded articular surface. Right below the head of the humerus, we see the neck of the humerus. As we turn the bone around and look at the medial view of the humerus, we see the lesser tubercle of the humerus. The greater tubercle is on the lateral side. In between the lesser tubercle and the greater tubercle, you have the intertubercular groove. The tendon of biceps brachii is going to run through this groove in life. As we come back slightly more caudal, we still see the head of the humerus. If you look at the proximal end, from its cranial view, what we see here, we see the greater tubercle, which is going to be on the lateral side, the lesser tubercle, which is going to be more on the medial side, and the intertubercular groove. From the caudal view of the bone, we see the head, which is the most prominent structure. The proximal end, it shows the greater tubercle again, lesser tubercle on the medial side, intertubercular groove. This is the cranial view of the humerus. The cranial view of the humerus, we see the proximal end, the cranial surface, and the distal end. From the caudal view of the humerus, we see the proximal end, the shaft body of the humerus, and the distal end of the humerus. Okay, let's go back to the proximal end, lateral view. So as we see the greater tubercle, below the greater tubercle, we see the deltoid tuberosity. The deltoideus muscle is attached to the deltoid tuberosity. The crest which runs between the greater tubercle of the humerus and the deltoid tuberosity is called crest of the greater tubercle, as well as the tricipital line. It's called tricipital line because the lateral head of the triceps is associated with that, which partially covers the brachialis muscle, which is located in the brachial groove. As we now look at the shaft of the humerus, we see the spiral groove, which is located on the lateral side. The muscle brachialis is located in this groove. Radial nerve is closely associated with the bone in the same brachial groove. Another important feature on the medial side of the humerus is going to be the teres tuberosity. As we see the medial view, we see the intertubercular groove as well as the lesser tubercle of the humerus. Below the lesser tubercle of the humerus, we see the teres tuberosity, which is attachment area for the latissimus dorsi and the teres major. The structure is not very prominent, but we can observe the roughness in this area, which indicates attachment of the muscles on the bone in this particular region. This is the teres tuberosity located on the medial side towards the shaft of the humerus, below the lesser tubercle of the humerus. Below the lesser tubercle of the humerus. Now let's look at the distal end of the humerus. The distal end, as we see it from the cranial view, the distal end as we see it from the medial view, the distal end from the caudal view, and the distal end from the lateral view. Now if you look at the medial and lateral sides of the distal end, the major difference is this extension on the medial aspect, which is not really present on the lateral aspect. The entire distal end of the humerus in general is called the condyle of the humerus. Now as there are two extensions, one on each side from the condyle, we call them epicondyles. On the lateral side, we have the lateral epicondyle. On the lateral side, we have lateral epicondyle. On the medial side, we have the medial epicondyle. On the medial aspect, we see the medial epicondyle. From the medial epicondyle, we see slight caudal extension, which also serves as attachment area for the flexor muscle tendons, and so sometimes referred to as the functional epicondyle of the humerus. Now as we look at the articular surface at the distal end, it is mainly divided into two parts. If you look at the cranial view of the distal end of the humerus, we see the articular surface. The articular surface basically is divided into two major areas: the capitulum, which is located more laterally, and the trochlea, which is located more medially. As we look at the distal end from the ventral view, we can still see the capitulum extended up to this point, and rest of the articular surface is the trochlea of the humerus. The trochlea of the humerus mainly articulates with the trochlear notch of the ulna, while the capitulum part of the humerus or distal end of the humerus mainly articulates with the capitular fovea of the radius. Few other features on the distal end as we're looking at the enlarged view of this bone. On the cranial aspect, we see the radial fossa. Roughly at the center of the radial fossa, we see a foramen which is called supratrochlear foramen because it is located above the trochlea of the humerus. From the caudal view, we see another depressed area or another depression here that is called olecranon fossa, and again roughly at the center of the olecranon fossa you're going to see the supratrochlear foramen as well. There are variations in the size of the supratrochlear foramen. Some of the bones they will have slightly larger supratrochlear foramen, while some of the bones they would have smaller supratrochlear foramen. Okay, these are the major features on the humerus. Basically in the dog, supratrochlear foramen is just to reduce the weight of the bone. There is nothing which actually passes through the supratrochlear foramen. Let's look at another specimen of the humerus of the dog. Here we see the supratrochlear foramen is fairly large as compared to the specimen that we saw earlier. The supratrochlear foramen seen from the caudal view, and the supratrochlear foramen seen from the cranial view. Here we have the radial fossa, and as we turn around, as we go on the caudal surface, we have the olecranon fossa. Radius and ulna. The bones which are present in the antebrachium part of the forelimb, the bones which are articulated with each other at their proximal ends as well as at their distal ends. This bone is from quite a young animal, and that's why we see at the distal ends the bone looks slightly swollen because the epiphyseal plates are not yet closed. At the proximal end, from the cranial view, we can see the part of the ulna which is protruding further upward above the radius, where we can see the epiphyseal or physis of the bone is still present. This part is olecranon, which is more on the medial side of the bone, while as it moves further distally, it is more on the lateral side of the bone. At the distal end specifically, as well as at the proximal end, bones are articulated with each other by means of a synovial joint. In between, along the shaft of the bones, there would be some space present between the bone which is called interosseous space, and also the interosseous tissue are present there connecting these bones with each other, as well as you will find your pronator quadratus located in between the bones in the live animal or in your dissection. Let's look at other specimen. And now we see the bones, radius and ulna from their cranial view. From the cranial view, we can see the olecranon process of the ulna, the head of the radius with capitular fovea or articular surface for the distal end of the humerus. The shaft of the radius, the cranial surface is convex, which looks slightly bulging more cranially. The distal end of the radius, on the lateral side we see the attachment of the or articulation with the distal end of the ulna. The distal end of the radius, on the medial side, the distalmost extension is your styloid process of the radius, and the distalmost extension of the ulna is the styloid process of the ulna. As it is located on the lateral side, we can still call it lateral styloid process, while this one is called medial styloid process. Right above the styloid process, we see the groove for passage of the abductor pollicis longus muscle. Let's go back to the proximal end. As we turn it from the as we see it from the medial view, we can see the olecranon process more clearly with olecranon tuberosity and corneal process, which is a beak-like projection. Then we see the trochlear notch, which fits into the trochlea of the humerus. The medial coronoid process of the ulna from the medial view, which is larger, and from the lateral view you can see small lateral coronoid process. You can still see the olecranon process here with olecranon tuberosity, which receives all the different heads of the triceps brachii muscle. Let's look at the radius and ulna individually. So here we are looking at the bone ulna, that is the cranial view of the ulna with its proximal end and distal end. As this is the cranial surface of the ulna, which is going to be in contact with the caudal border or caudal surface of the radius, we can see some areas for attachment of the connective tissue as the bones are in contact with each other. At the proximal end, from its cranial view, on the medial side we see the larger medial coronoid process and smaller lateral coronoid process. The trochlear notch, the encorneal process of the ulna, the olecranon as we see it from the lateral view, and the olecranon tuberosity, which is seen from the lateral view but look at it more caudally. From the medial view, we can see the olecranon with olecranon tuberosity, encorneal process, trochlear notch, and the medial coronoid process. The distal end, the tapering part of the distal end, this is called lateral styloid process or styloid process of the ulna. The bone radius, as it is seen from its cranial view, the proximal end of the radius, the distal end of the radius, the cranial surface, the convex and smooth surface. As we turn it around, we can see the caudal surface of the radius, which is slightly rough because of attachment of the connective tissue as well as close association with the bone ulna on its caudal surface. The caudal surface is concave while the cranial surface is bulging forward, which looks more convex. At the proximal end, the structures that we see, the capitular fovea, the articular circumference. As we come further down, at the distal end of the bone, we can see that is the medial side. On the medial side, we see the styloid process of the radius, groove for the passage of the abductor pollicis longus, and the passage for the tendons of the extensor carpi radialis as well as common digital extensor. That portion would be called trochlea of the radius. This is articular area for the ulna, and then we see the distal articular surface of the radius, which majorly articulates with the radial carpal bone. After looking at the radius and ulna, let's now look at the skeleton of the manus. The skeleton of the manus is formed by the carpal bones. As we know, there are 7 carpal bones in the dog. Then metacarpal bones, typically 5 metacarpal bones in the forelimb as digit number 1 is present. And then the phalanges, where we have 3 phalanges, 1, 2 and 3, forming each functional digit. While in the non-functional digit, we only have phalanx 2 and phalanx 3. So in this view, we see the cranial view of the carpal bones. As we see digit number 1 on this side, that is your medial aspect, and from medial to lateral, we can actually see the proximal row of the carpal bones. We see the radial carpal bone and the ulnar carpal bone. The radial carpal bone is formed by fusion of intermediate carpal bone, which is supposed to be present here, and radial carpal bone, which is more on the medial side. So in the dog as well as in the cat, we see that intermediate and radial carpal bone, they fuse together to form intermedioradial carpal bone, or simply we can call it radial carpal bone. So the one on the medial side is radial carpal bone. As we go more laterally, we see the ulnar carpal bone. Then as we go more laterally and slightly on the caudal aspect, the bone which protrudes backward on the palmar surface of the manus, that is the accessory carpal bone. This is the caudal view of the carpus, where we see the accessory carpal bone. Then we see the radial carpal bone on this side. From the top view, we can see the articular surface of the radial carpal bone, which basically articulates with the articular surface of the radius, and we have the ulnar carpal bone, which articulates with the ulna, as well as more caudally it articulates with the accessory carpal bone. Let's go back to the dorsal view. From the dorsal view again, as we start from the medial side, we see the carpal bone number 1, carpal bone number 2, carpal bone number 3, and carpal bone number 4. Number 4 being the largest one, number 3, 2, and 1. More on the medial side of the carpal bone number 1, between the radial carpal bone and the carpal bone number 1, located is the sesamoid bone within the tendon of abductor pollicis longus muscle. We can see it from the medial view, as it is located on the medial aspect. As we come further down, we typically have 5 metacarpal bones in the manus of the dog. Metacarpal bone number 1, metacarpal bone number 2, 3, 4, and 5 from medial to lateral. Let's consider the metacarpal bone number 3, and we'll consider different parts of the metacarpal bone number 3. The proximal end of the metacarpal bone, which is called base of the metacarpal bone, and the middle part of the bone is usual shaft or body of the metacarpal bone, and then at the distal end we have the head of the metacarpal bone. The head of the metacarpal bone is still extended further below rounded articular surface, which from the palmar side will also show a little ridge in the middle of the articular surface of the head. So this is the caudal view. We can see the metacarpal bone number 1, metacarpal bone number 2, 3, 4, and 5 respectively from medial to lateral. As we come slightly below that, we are still looking at the palmar view of the manus or skeleton of the manus. We can see the 2 smaller bones located at the junction of metacarpal bone and the proximal phalanx. Those 2 smaller sesamoid bones are the proximal sesamoid bones. At the same level, on the dorsal aspect, we expect the dorsal sesamoid bone located at each functional digit. But then in this preparation, those bones might have lost because we have removed the tendons of the common and lateral digital extensor from the respective digits. So this is the location for the dorsal sesamoid bones, 1 per functional digit, and that is the location for the proximal sesamoid bones, 2 per functional digit. Okay, let's move further down to the phalanges. Phalanges have same structure as the metacarpal bones. The structure of the phalanges is quite similar to the metacarpal bone. Basically, they are shorter in length. The proximal end is called base of the phalanx. The middle part is shaft or body of the phalanx, and distal part is head of the phalanx. So we have 3 such phalanges which form 1 digit: proximal phalanx, middle phalanx, and the distal phalanx. The middle phalanx is shorter than the proximal phalanx, but structurally same. But the distal phalanx differ from both of these phalanges drastically, which resembles the shape of the toenail. The major part of the distal phalanx which is visible is the ungual or unguicular process of the distal phalanx, which actually bears the toenail on the surface of the unguicular process or ungual process of the distal phalanx. Let's look at one of the isolated distal phalanx. As you see the distal phalanx here from its lateral view, it could be either axial or abaxial view of the distal phalanx. We see the base of the bone which articulates with the middle phalanx. Then here we have the ungual crest or unguicular crest more on the base of the bone, as well as on the caudoventral part we have the flexor tubercle of the distal phalanx. Ungual process or unguicular process of the distal phalanx. As we see the bone from the cranial view, we can see the ungual crest. We can see some gap between the ungual or unguicular process and the ungual crest or unguicular crest. At the dorsalmost aspect of the unguicular crest, we have attachment of the extensors, the common digital extensor, as well as the dorsal elastic ligaments, and that structure is called extensor process of the distal phalanx. So the major parts of the distal phalanx are the base of the bone, then the ungual or unguicular crest, and the ungual or unguicular process of the distal phalanx. Flexor tubercle and extensor process on top, while flexor tubercle on the caudal as well as ventral aspect